I always think that this is a fun example for the quotient rule. We all know that the derivative of tangent is secant squared, but it further validates that derivative and perhaps even this method. And so when we look at the derivative of tangent, the first thing I do is turn it into a quotient of expressions, sine x over cosine x. And then when we apply the quotient rule, it says that we would go low d high, so cosine x times cosine x, the derivative of sine is cosine, minus high sine x, derivative of the bottom, derivative of cosine is negative sine, over the denominator squared. My next line, I know that cosine times cosine is cosine squared, and then I have two negative signs here. Negative sine times negative sine would be plus sine squared x over cosine squared x. This numerator is one of our Pythagorean properties for trigonometry. Cosine squared plus sine squared is 1. And so this becomes f prime of x equals 1 over cosine squared x. And remember, as an identity, 1 over cosine is secant, so 1 over cosine squared would be secant squared x. And we show by using the quotient rule that you can go from tangent x, take a derivative, and it gets you to secant squared. Example 3 for the quotient rule.